So today's topic is DP, dynamic programming. It is a powerful algorithmic technique used to solve problems by breaking them down into the smaller sub-problem and solving each sub-problem only once, right? This is important, only once, and storing their result to avoid redundant work. Let's say we have calculated for, let's say we are having the one function we have calculated for int x when x is 5. So we have calculated for 3. Now again we will not be calculating for 3. We will be using the same sum as we are having here, right? So this is the benefit of DP. We will be storing the result and will be using the same result instead of calculating again and again, right? So when to use? When you are having a overlapping sub-problems are solved multiple times. In that you will be storing the values, the result, and using the same. For example, Fibonacci series, right? After that, optimal substructure. Now there will be a problem depend on the optimal solution of its sub-problems, right? So basically we are storing the values, right? The results. So it will be optimal solution. So that's what and why it helps. Instead of recalculating the result for the same input multiple times, like in the plain recursion, DP saves the result in the memory and reuse it, right? Let's say we are having the x initially as 5, right? Now we are started with a 5. Okay, now we will be recursively calling x minus 1, right? And one more, find x minus 2. This is example, right? Within this find function, we are recursively calling these two functions again. Okay, so for the 5 we will be calling 4 and 3, correct? X minus 1, x minus 2. For 4 again we will be calling 3 and 2, right? Here now let's say we have calculated the value for find x. Now when it will come to this 3, again we will not call the sub problems, we will simply use the result from this value. Got it? Let's say we are having the DP. In the DP we will be storing the results. For DP3 some value will be there, we will be using the same value here instead of calling the child again and again. Got it? Simple thing, right? Let's say now in the DP we are having 3 approach. First is top down, that is also called recursion with memorization, right? This is basically a recursion and some storage will be there which will store the result in a table. Okay, the simple example is Fibonacci. Second one is bottom up. This is top down, this is bottom up. I will tell you. Okay, this is tabulation form. In this we will be solving the problem iteratively using the for loop. We will be converting this solution into this for loop. We will check how. And third one is space optimize. Now here we will be optimizing the space. Okay, we will be storing only the required result. Okay, let's deep down into these 3 categories. For some value we will be storing the results and we will be using that results again and again instead of finding the solution. Okay, let's understand this first approach, that is top down approach, memorization that we call. It is basically recursion with memorization, correct? Now why this name, why this top down? Because we are starting from the main problem and we are breaking it down into the sub problems recursively, right? We will see the example using the Fibonacci series. With that it will be clear. And memorization, what is memorization? Basically we are storing the answers to the sub problems in a table, that is DP, to avoid recomputation or recalculation, correct? So these are the characteristics. Uses recursion, uses a cache, that is DP, memorization, and useful when you are comfortable thinking recursively. Okay, so let's talk about the Fibonacci series. What is Fibonacci series? It's basically the sum of last 2 numbers, right? Let's say we are having 1 0 1. The next number will be sum of 2 numbers, last 2 numbers, that is 1. Now it will be 2, now it will be 3, now 5, now 8, right? And so on, right? So this is the sum of 2 previous values. Got it? That is, we can say what? The f of n will be f of n minus 1 plus f of n minus 2, correct? We can say this is the formula, right? Now, how can we apply DP? How can we apply recursion? So now how to apply this top-down approach? What is top-down approach? Basically, we will start from the main problem, break down into the sub-problems, okay? So I'm saying we will start the recursive function. Let's say Fibonacci is there and x will be there. We are calling for the main problem 5, right? We want to get the element, the fifth element from the Fibonacci series, right? Get fifth element from Fibonacci series, correct? So we have called for the main problem, that is 5. Now we will break it down. What is the value? We will apply this formula, that is sum of f n minus 1 f n minus 2, correct? So we will call the recursive function for f n minus 1, that is what? That is 4, right? 4, and f n minus 2, that is 3, right? Again it will go recursively. Again for this f4 it will call for what? F n minus 1, 3, f n minus 2, that is 2, right? Again it will call for the same, right? What is the value now? F2, F1, right? And what's next? F1, F0, right? This is basically the kind of diagram, the flow, right? Understood? We are using this formula recursively, and I'm saying this is how we will apply the recursive function on this particular problem. Now for these two values, I'm saying these are the base condition. It will be having value for f0, it will be 0, for f1 it will be 1. Okay, these are the base conditions, right? After that it will return, right? It will return sum of both. It will be 1, f of 2 will be 1, f of 1 it will be 1, base condition. Now f of 3 plus, right? f2 plus f1, 2, go up, right? F of 2 we already calculated, right? It's already calculated. So f of 2 as calculated we can store in the DP. DP of what was the base condition? DP of 0 was 0, DP of 1 was 1. These are the base conditions. Now we have calculated what? DP of 2, that is what? 1, right? 1. Now we have also calculated DP of 3, that is 2. Okay, now f of 2, DP of 2 is already there, this is there, so we will use the same, that is 1. Okay, sum is 3. We got DP of 4 as 3, got it? And Fibonacci of 5 will be DP of 4 and f of 3, correct? It's already there. We already calculated DP of 3. That means Fibonacci of 3. The result is 2. So add it. The answer is 5. 3 plus 2 is 5. Right? So we got the fifth number from the Fibonacci series is this one. Okay. Now how can we code this? Let's say we are having the DP in the main function. Right? DP is there. Okay. Now let's write this recursive function, let's say Fibonacci with memorization. Okay, now we will be having what? This DP will be there, right? DP, and what else? The n will be there, right? For which value we are calling this recursive function. So int n, right? Now what is the base condition? These are the base condition, right? Let's write it. If n equal to 0 or n equal to 1, in this case we will simply return what? Return n, right? This is the base condition. It's completed. Now what's next? Now we are calling for the n, this recursive function, right? So we will check if it's already calculated or not. So if DP of n is not equal to -1, that means it doesn't have any value. it is not calculated yet. Sorry, opposite, right? It's calculated, its value is not equal to -1. Initially all values are -1. We are checking if its value is not equal to -1, that means it's calculated, we will use the same result. So return dp of n. Got it? We are returning the same result. Now what's next? We are calculating this formula. Yes. So return dp of n equal to what? Fibonacci memoization. We will call the n-1 and n-2, right? dp as it is, n-1 plus, right? Plus, we need to do plus Fibonacci memoization, the recursive function, with n-2. Correct. So this is the simple code for this dp with memoization. You can also check with this example with the 5. We are starting with the 5, right? We are starting with the 5, let's say. Then we will check, this is not the base condition, this result is not there. We will call for 4, that is n-1 and 3, right? So first it will call for the 4, complete all the leftmost, right? Depth, correct? Means if you see here, this depth first, right? It will complete this depth, right? So it will cover for 4, then 3, then 2, then 1. We will get the base condition, go back 2, we will get the sum and add it in the dp, go back, like this, the same which I explained here, right guys? What is the time complexity here? What we are doing, we are traversing each and every node, right? So it will be of n, right? After that space will be, we are using extra space, that is dp of n for this. What else? We are using the recursive function, so it will be again of n for the stack. So of 2n for the space, of n for the time. This is the first approach, that is recursion with memoization, that is top down approach, right? We are having the main function and we are calculating the sub problems and adding them recursively. Got it? Now the second approach, bottom up approach, right? First one was top down, it's bottom approach. Bottom up, right? It's opposite. So bottom up approach. In the first type, we are having the main function, that is the main the largest input, right? And we are calculating the sub problems. But in this, what we will do? We will do the opposite. We are having the base case. What was the base case? Base case was if n equal to 0 or n equal to 1, return n. That means dp, let's say Fibonacci of 0 will be 0, Fibonacci of 1 will be 1. Now what we will do here? We will be using these base conditions and form up the result for the higher value, opposite of first one, right? So bottom up, we solve the smallest sub problem first, use them to solve the bigger problem, right? Tabulation, we will be storing the result in the array to store the result in the bottom up fashion, correct? In this, we will be using the loops, no recursion, build the solution from the base case upwards, right? And more memory efficient than the top down because recursion is not there. So no stack storage. Okay, so in this, if you see this diagram, the tree diagram, we are having these base conditions, right? Now in this second type, we will be using these base conditions, add them, get the result for f2, again we will add them, get the result for f3, again we will add them, get the result for f4, and so on. Got it? Got the intuition? Basically what we will do, in most of the questions you will be checking this recursion thing only, recursion code, and try to convert it into the iterative approach, that means the for loop, correct? So what we can do, see, we are having the base condition, right? Base condition is there, this is the base condition. So let's add this second type. What is the type of this? Tabular form, right? So now base condition is will be what? dp of 0 will be 0, dp of 1 will be 1, right? We have converted this base condition into this thing, correct? So what's next? We are doing what? We are checking if value is there or not, right? We will be checking this in the for loop, correct? So let's having the for loop. Instead of recursion, we will be having for loop. For loop will start from the second index, right? For 0 and 1 we already have the value, we need to calculate it from 2 and onwards, right? I is less than equal to n I plus plus. Now we will check what? dp of I will be equal to what? dp of I minus 1 plus dp of I minus 2, right? Correct? And this is how we will get the all the Fibonacci series. At the end we will return dp of n, that is the given input. That's it. What we are doing here? We are just converting this recursive thing into the iterative form, right? We are having the base condition, we got the base condition. What we are doing next? We are having the recursive calls, right? For each we are checking the n minus 1 and n minus 2. So that's what we are doing here. We are getting the value of dp of I is equal to dp of I minus 1 plus I minus 2, same as here, okay? And here this is what? This is bottom up, right? We are having the base conditions, that is 0 and 1. Let me write it here. So we are having this tabular form, correct? So what we are doing here, basically it's bottom up, right? Bottom up. So we will try to solve the smaller item first, then we will be using that smaller item to calculate the higher value, correct? So we need to calculate for 5, let's say, okay? So we will start from the smaller values, that is 0 and 1. Then we will start iterating this for loop as we are doing in the recursion, right? We will be applying same formula and we will be using the smaller sub problems, right? That is dp of 2 will be what? dp of 1, that is 1 plus 0, correct? Now dp of 3 will be dp of 2, that is 1 plus dp of 1, that is 1. dp of 4 will be dp of 3, that is 2 plus dp of 2, that is 1. So 3, and dp of 5 will be 3 plus 2, 5, right? Simple form, but in some questions it will be difficult to convert this recursive code into the tabular form in some questions. Here it's easy, right? Okay, now the time and space complexity. Time will be what? Simple, we are iterating this for loop, it will be of n. What about space? Space will be, we are using dp, right? So again it will be on. Now recursive stack is not there, correct? So something we have optimized from the first approach. Now the third approach will be space optimization, right? Now here we have optimized the recursive to the iterative, right? We are having the for loop and we are calculating the Fibonacci series, that is what? Fibonacci of I will be equal to Fibonacci of I minus 1 plus Fibonacci of I plus minus 2, right? Using this formula, and we are having the dp, correct? Now here we will be optimizing our space. We will be using what? by noticing that we don't need the whole DP array, just we need a only few previous values. So in this code, what values we are using? We are using the I-1 and I-2, right? That means for I we will be checking I-1 and I-2, correct? So whole array we don't need, correct? We will be needing only these two values. So can we use some variable like this is prev1, this is prev2, and we will be maintaining for I these two last values, correct? For I-1, I-2. So here we are not using whole DP, we will be using only few variables. In this case it's prev1, prev2, that is I-1, I-2, right? Prev1, prev2, correct? Can we do this? Basically in the space optimization, what we will do, we will convert this DP into the smaller thing, right? If let's say if this is a 2D array, DP 2D array, right? And this we will be converting this into the single array, single dimension array, that is 1D array, because we will be checking the previous row only. I will show you example of this in tomorrow's session, but in this case we are using the previous two arrays, so we are not using whole DP, we will be using these two variables. So what should be the code for this? Let's say we are having the tabular form, let's convert this. Okay, now we are not using the DP, full DP, we will be only using this maintaining these two variables, right? So let's write the code. Fib memo int n, right? So first is int prev2 for the 0, right? Int prev1 for this 1. After that for loop same, int I equal to 2, I less than equal to n, I plus plus, right? What's next? Now let's calculate the current sum, right? That is previous 2 plus previous 1, plus previous 2, correct? We got the current element, right? That is the sum of last two variables. Now what's next? Now we need to modify this prev1 and prev2, right? Prev2 will be what? Prev1 now, and prev1 will be current now. Just swapping, right? Return the current element. What is the current element now? The prev1, right? Let's take the example and understood this. So let's say we are having 0, 1, correct? This is prev2, this is prev1, right? Now we will calculate the next variable, that is sum of these. In this case it's 1, right? 1, this is what we are taking current variable, right? Now we need to move this prev2 and prev1 for the next number, for calculating the next number, right? So now we will move this prev1, it will be here now, it will be here, that is equal to current, and prev2 will be here, right? Prev2 equal to prev1 and prev1 equal to current, right? So this is how in the next iteration we will calculate this current again. Now this is current, again we will be swapping the values, right? Now prev2 will be prev1 and prev1 will be current, right? We will get the next current using these two variables. Understood? At the end this prev1 will be the last element that we need to find, correct? What is the time and space complexity? Time will be same, right? On, we are having the for loop which is iterating all the n nodes. Space, what about space? We are not using extra space, right? So it's constant. So this is the benefit of space optimization, right? So these are the all three approaches. The first one is top down, that is memoization with the recursion, and second one is bottom up, right? We are having the smaller sub problems, then we will use them to solve the bigger problem, right? The third one is space optimization. We will be using the less space, the needed one, we will be using the needed one values, and these are the time and space complexities which I explained you. House robbers. Okay, let's solve this. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money. The only constraint stopping you from robbing each of them is adjacent houses. Okay, have security system connected and it will automatically contact the police if two adjacent houses were broken into the same night. Okay, means we can't rob two adjacent houses, correct? Now return the integer array nums representing the amount. Okay, it's given the integer array nums representing the amount of money of each house. Return the maximum amount of money you can rob tonight without alerting the police. Okay, so we need to get the maximum money, but we can't rob two adjacent houses. Got the question? This is the array given, right? 1 2 3 1. These are basically what? The amount of money in each house, right? So in 0 house it's 1. For 1 house the amount of money is 2 rupees. For 2 it will be 3. For 3 it will be 1, right? Now you can't rob adjacent houses, means if you rob this 1 you can't rob 2, right? So if you rob this 2 you can't rob 1 and 3. Got it? So means if you rob, let's say rob 1, then you can rob what? Next will be 3. That means if it is I plus 2, right? Correct? And if you are not robbing this I, then you can rob I plus 1. Understood? If you are robbing this I, then you should rob I plus 2 next. If you are not robbing, that means skip, then you can rob the I plus 1. I plus 1 we can't rob, correct? So we have the two things, right? Either we can rob it, then this is the next call will be I. First we will add it, right? And recursively call what? I plus 2, right? Otherwise if we are skipping this, then what? Then simply call the I plus 1, the next house, correct? In this we will be adding the money, and this we are not adding the money, correct? Two cases are there, so two calls will be there for recursive, right? So let me write the pseudo code for this. Okay, so we know the two cases will be there. What we should do? We should check each and every possible solution, and we can do using recursion, right? Possible solution. The first thing is recursion. Brute force approaches recursion, right? We will check two things. Either we will rob this house or we will not, right? Either we can skip or rob it, right? This is let me write it. Let me show you the diagram. Okay, we are having the 1 2 3 1, right? This is the given array, right? The money, right? So for the 1, let's say we are at 1, so we will be having two cases, right? Two cases will be there. Either rob it. If we are robbing, then we will do plus, then what else? Then call the same function with what? With this 3, right? 3. And here if we are not robbing, then what? We will simply call the recursion of second, correct? Now next, what next? With the 3 again we will be having two conditions, right? What are the conditions? Either we will rob it, that means 3 plus the next is not there, right? It's not there. And here we will call the recursion of 1, correct? If we are not robbing this, right? For this again we will be adding this or not adding this, right? So nothing will be there. right? So it will return, right? It will return here, we will get 1, right? Here 3, we will take the maximum of both 3 or 1. 3 is higher, so we will get 3. Again recursion of 2, let's calculate this one also. For 2 we will be having 2 cases, either we will take this, that is if we are taking, then we will be taking this, and the next one, that is plus 2, that is 1, recursion of 1. If we are not taking this, then what will be the case? Recursion of 3, right? Again we will calculate this value 1, here the value was 3, right? So we will be using the same recursion, that is 3, right? 3 here, correct? So let's go upward. So here it will be 3 only, right? For this it will be 1, and 2 plus 1 is 3, the maximum is 3 only, so 3. So here 3, here the value is 4, right? 1 plus 3, 4. So we will get the maximum value as 4. Okay, understood? Just we need to calculate two things, either we are taking this or we are not taking this, and we will be taking the maximum of both in each recursive call. Shall we try to code it down? We are having two calls, rob it or skip it. If we are robbing it, then we will be adding the value, plus we will be calling the same recursive function with I plus 2, because the next house we can't rob. If we are skipping this, then we will call the next I plus 1 only, right? So let's write the code. So let's say dp is there, let's say, okay, function name, right? We will be having what? Int I, for which index we are calling this recursive function. The int nums will be there, right, for calculating the values, and 1 dp, right? So this function we will be calling from the main function. Okay, after that what we will do? If the base condition will be there, if I is greater than equal to nums dot length, then what? Return 0. This is the base condition, right? If I goes out of the bound, return 0. Otherwise we will check if this solution is already there or not. Is not equal to -1, then return dp of I, right? After that we will be having two conditions. First is rob it, and second one is skip it. So we will calculate both. So int rob, we will be having what? Nums of I, we will add the value, plus we will call this recursive function, that is dp of I plus 2, for I plus 2, right? Nums as it is, dp as it is, and next int skip, right? For the skip we will simply call the recursive function for I plus 1, means move to the next house, nums dp. At the end we will store this value, the maximum of dp of I will be equal to the math.max of both, right? Rob or skip. Then what? We will return this dp of I. That's it. This is the simple logic for dp. This is the base condition. We are checking if already calculated or not, right? After that we are having two conditions. First is rob. If we are robbing, then we will be adding the value of that house, plus the next house we can't rob, so we will be taking the I plus 2 as the next. And second thing is skip. We can skip the current house, then we will be checking the next one. Then we will be adding the value of, basically storing the value of max of both rob or skip, right? If you see this example, we will be having the bigger problem, then we are solving for the smaller ones. At the end we will get some value, we will go up adding the values, and ultimately we will get the value for the main problem, right? This is what top down approach, the recursion with memoization. Now this is the first approach, that is recursion with memoization, right? What about next? It's bottom up, right? Bottom up. Now we will try to convert this recursive into the iterative one. How we can do? See, what was the example given? 2, 3. So we are given the array 1, 2, 3, 1, right? And we are proceeding from here to the end, right? In the top down approach. In this bottom up, let's say we are starting from the last, from here. From here, what is the maximum? Let's say we are at this index. Which option we have? We will take this value, right? We are only having the last value. We will take this. Let's say dp of n minus 1 will be what? Will be the nums of n minus 1, correct? We are not having any option, so we will take it as it is, store in the dp, right? And what about n minus 2? This value we have the option, right? We can take the maximum of both, either this one or this one. We are starting from here, right? So what we can do? We can take the maximum. So max of num of n minus 1 and nums of n minus 2, right? We are taking the maximum of both, right? So what's next? Now we will start the for loop. After this value we will start the for loop, and we will taking the maximum. That means two conditions were there, right? First is rob it. In the rob, what we are doing in the rob, we are adding the value, we are calling for the I plus 2. Same thing we will do here. For the rob, we will do what? We will take the value, that is nums of I plus dp of I plus 2. Got it? And if we are skipping this, then what? dp of I, right? Now we are having the values of these two, right, as the base condition, correct? This is the base conditions. After that we will start from this. Now we will be checking if we are robbing this, then what value we will get? That is nums of I is 2 plus dp of I plus 2. That is maximum of both. Sorry, dp of I plus 2 is this one, right? That is 1. We are not taking the next value, the adjacent one. So it will be 3. If we are skipping this, then what? dp of I plus 1, right? dp of I plus 1, that is this value, right? This value. So it will be what? It will be 3 only. So we will take the maximum of both. dp of I equal to max of rob or skip. That's what we are doing earlier, right? We are taking the maximum of both. This is the formula for rob, this is the formula for skip, right? So what we are doing here, we are making the base case for the last two, right? After that we are calculating the rob and the skip for each index, right? Currently we are at this index, we are calculating the rob, that is the value is 3. We are calculating the skip, that is the value is 3, and we will take the maximum of both. So at this point let's make the dp array also. So it's empty. The value was here, the value was 1, here the value was 3. So 3 comma 1, right? We got the value 3 here for the 2, right? Now the next, this last one, rob. What is the value for the rob? Nums I, that is 1 plus dp of I plus 2, that is this value, right? That is 3. We got the value as 4. Same with skip. What is the value? dp of I plus 1, that is this one. The value is 3. So we got the maximum as 4. We will store it here. We got the value 4 plus 1 here. Okay, let's write the code for this. So let's write it here. So the two conditions will be there. Let's say int dp will be there, right? So it will be of n size, new int n size. We will fill this with -1 arrays.fill function. After that dp of n minus 1 will be n minus 1 only, right? Will be nums of n minus 1. because this is the last number. We don't have the options, right? We will take the value as it is. After that, dp of n minus 2. Now we are having two values. We will take the maximum of both. Math dot max what dp of n minus 1, or we can also use the nums. Let's write it, and nums of n minus 2. Correct. Now these are the base conditions to solve the bigger problem. Now we will start from the reverse order, right? We will start from int I equal to n minus 3, right? Because two values we already calculated, and I is greater than equal to 0, I minus minus. We are going in the reverse order. Then what next? dp of I will be equal to math dot max what? The rob. What is the formula for rob? That is nums of I plus dp of I plus 2. Correct. And what's next? If we are skipping this, then dp of I plus 1. That means move to the next variable. We can take the next variable, right? That's it. At the end, we will return dp of 0. That will be the result. That's it. This is the second, that is bottom up. We are trying to convert this recursive function into the iterative one, right? You can form the link between them. It's easy, right? Just try to check this condition, this thing, like how to convert this recursion thing into the tabular form. This will be important because in some question you can't be able to form this tabular form. Just try to solve this and then think the logic how it's working. The time will be off and the space will be off and, because we are using the dp, right? Now what's next? The third form was space optimization. How we can do this? How we can optimize our space? What are the variables we are using? We are using dp of I plus 2, dp of I plus 1. The two variables, like in the Fibonacci series, we are using n minus 1 and plus n minus 2, right? Here we are using n plus 1 and plus 2. Same thing, right? We can use two variables and we can optimize our space, right? Shall we simply code this? It will be same, just we will be using two variables instead of dp. Let's code this. Okay, so first thing, we will be having int next one, that will be equal to what? That will be equal to this one, that is math dot max dp of, not dp, nums of n minus 1 and nums of n minus 2. Okay, what's next? Next 2. Here we will be using nums of n minus 1. Correct. So if you see the problem, we are having what? 1 2 3 1, 1 2 3 and 1. So I am taking this one as next 2, this one as next 1, right? So now we will start the same for loop int I equal to n minus 3, I greater than equal to 0, I minus minus. What's next? dp of, now dp is not there, we need to use third variable, that is current. We will find the answer, and current equal to math dot max, same thing, right? Nums of I plus what? Next 2, right? Next 2, this one. If we are taking the current element, we can't take the next element, we will take the next of next, right? We are taking next 2. Then what else? Here it will be next of 1 only. Understood? That's it. Then at each step we need to modify this also. Next 2 will be now next 1 will be current. At the end we will return the current element, that is next one, right? Let's say we have calculated this current, right? Now the n1 should be here, n2 should be here, so that's what we are doing. N2 is equal to n1, n2 is equal to n1, and n1 equal to current. I hope it's clear. Here the time complexity will be of n, the space will be of 1, constant space, we are not using extra space.